थोड़ा रुक के पर हाँ पर पहली गल तो कि कल दे मेरे तुहाडे नाल इंटरैक्शन का मैं तो बहुत खुश सा। तुहाडा मैनूं पता नहीं कि तुसीं खुश होए कि नहीं होए, क्योंकि मैं कई मामलों च बाहर रहिंदिआं इंडियन स्टूडेंट्स नूं थोड़ा जिहा अंडर एस्टीमेट करन लग, पर वो तुसीं मेरा काफ़ी हद तक वहम लाया कि नहीं कि तुसीं भी बड़े एक्टिवली पार्टिसिपेट कर सकते हो जे तुहानूं मौका दिता जाए। तो एक तो एक सियाणियां गल्लां तुहाडे अंदर भी हैगियां ने जिहड़ियां तुसीं सांझियां करन नूं तैयार हो। सो इस चीज़ का तो अपनी भाणजी नूं सोशियोलॉजिस्ट नूं भी राती दसदे पिया सां, क्योंकि वो मैनूं यही पुछदे सी कि भी बच्चों नूं सोशियोलॉजी पसंद भी आएगी, समझ भी आएगी। मैं क्या भी नहीं, जिस किस्म का मैनूं लगदा उन्हां दा दिलचस्पी तो होएगी। ये बाकी टीचर पर भी डिपेंड करता कि तुसीं उन्हां नूं किवें उहदे च इनवॉल्व करदे हो। सो उस गल दा तो तुहाडा सारिਆਂ दा थैंक यू कि तुसीं मेरा जिहड़ा पुराना वहम है उन्होंने घटाया। पूरा तो नहीं उतरेगा क्योंकि उन्होंने टाइम लगेगा, पर वो घटिया कि तुसीं काफ़ी एक्टिवली पार्टिसिपेट कर रहे हो। तो अपने विचारां नूं देण दे विच कोई झिझक ना महसूस करो, क्योंकि जिवें मैं दस्सिया कोई भी विचार ठीक नहीं है या कोई भी विचार गलत नहीं है। हाँ, तुसीं जो कहोगे मैं उल्ट बोलना है। एक तो वो एजुकेशन का हिस्सा कि जस्ट फॉर द सेक ऑफ एक्सटेंडिंग द आर्गूमेंट। वो मैं गुरचरण जी को कल दस रहा था कि इटली से जो साल हो कोर्स शुरू किया तो उत्थे साडे कोल टाइम बड़ा सी 2 हफ्ते 25 स्टूडेंट सा 5 टीचर सा 2 हफ्ते असीं इकट्ठे सा सवेर तो शाम तक। उहदे विच फिर हरेक सवाल नूं असीं उदों तक घसीटदे सां जां डिस्कस करदे सां जद तक होर कुछ कहण नूं रह नहीं सी जांदा। ਉਹਦੇ ਨਾਲ ਫਿਰ ਉੱਪਰੋਂ ਫਿਰ 15 ਦਿਨ ਦਾ ਕੋਰਸ ਸੀ, ਸਵੇਰ ਤੋਂ ਸ਼ਾਮ ਤੱਕ ਖਾਂਦੇ ਵੀ ਇਕੱਠੇ ਸਾਂ, ਸ਼ਾਮ ਨੂੰ ਬਾਹਰ ਵੀ ਰੈਸਟੋਰੈਂਟ 'ਚ ਵੀ ਇਕੱਠੇ ਜਾਣਾ, ਹਰ ਸਮੇਂ ਹਰ ਚੀਜ਼ ਇਕੱਠੀ ਹੋ ਰਹੀ ਸੀ। ਪਰ ਉਹ ਆਪਣੇ ਆਪ 'ਚ ਵੱਖਰੀ ਕਿਸਮ ਦਾ ਐਕਸਪੀਰੀਅੰਸ ਸੀ। ਉਹ ਇੱਥੇ ਹੁਣ ਸਾਡੇ ਕੋਲ ਹੈ ਨਹੀਂ ਟਾਈਮ, ਇੱਥੇ ਤੇ 11 ਤੋਂ 1 ਤੇ 2 ਘੰਟੇ ਹੀ ਯੂਜ਼ ਕਰਨੇ ਬੜੇ ਹੋ ਜਾਂਦੇ ਨੇ ਕ੍ਰਿਟੀਕਲ। ਸੋ ਕੱਲ੍ਹ ਅਸੀਂ ਜਿਹੜੀਆਂ ਗੱਲਾਂ ਅਸੀਂ ਸੈੱਟ ਕੀਤਾ ਸੀਨ ਹੈ ਤੇ ਕੋਰਸ ਉਹ ਕਿੱਥੇ ਮੇਰੀ ਯੂਐਸ ਪਰ ਕਿਹੜਾ ਲੈਕਚਰ ਕੀਤਾ ਤੁਸੀਂ ਡਾਊਨ? ਲੈਕਚਰ 2 डाउन किया। ठीक है, अज हाली 1 तो शुरू करांगे ना कि कल जी असी पहले मेन गल्लां करते गए हैं। ਇਹਦਾ कित्थे गया जी तुहाडा? ਤੁਹਾਡੀ बैकग्राउंड वगैरह ठीक चल रही है मेरे कोर्स के लोड़ अनुसार। वो मैं दस रहा था, मैं इस जी तुहानूं किताब दी है छोटी जी, वो पहले सफ़े तो मैं कोई लिखा होया है कि वट इज़ एक्सपैक्टेड फ्रॉम यू, कि मैं तुहानूं जिवें बेसिक बायोकैमिस्ट्री नहीं पढ़ा रहा। आई एम जस्ट फीलिंग इंट्यूटिवली इज़ वन ऑफ द स्टूडेंट्स। कैन यू अंडरस्टैंड पंजाबी? Yeah, okay, then you should have please told me because I thought Justin is not here, that's why I just forgot you. Hindi आती है? Okay, so I will be mixing. Oh, sorry, because I didn't judge that. So that there are certain things expected from you, basic biochemistry and biomolecular biology knowledge. That's not what I am going to teach you here. That how DNA gets repaired, or how protein synthesis happens, or how cells divide, what is a cell, or this and that. So those are expectations, and also we will be bringing you more active into some. So I wanted to go to our question from yesterday. Oh, sorry, can we go back? How do we go back? Okay, well, we are coming to that. ਉਹੀ ਮੈਨੂੰ ਚਾਹੀਦੀ ਹੈ ਜਿਹਨਾਂ ਨੂੰ ਮੈਂ ਵਾਪਸ ਵੀ ਜਾ ਸਕਾਂ, ਕਈ ਵਾਰ ਗਲਤੀ 'ਚ ਆ ਜਾਂਦਾ ਨਾ ਅੱਗੇ। ਸੋ ਕੱਲ੍ਹ ਅਸੀਂ ਗੱਲ ਇੱਥੇ ਛੱਡੀ ਸੀ ਕਿ ਅਸੀਂ ਗੱਲ ਕਰਨੀ ਹੈ ਲਾਈਫ ਲਿਮਿਟਿਡ ਕਿਉਂ ਹੈ, ਕਿ ਵਾਈ ਲਾਈਫ ਇਜ਼ ਲਿਮਿਟਿਡ। ਸੋ ਉਹਦਾ ਜਵਾਬ ਜਿਹੜਾ ਹੈ ਉਹ ਸਾਇੰਟੀਫਿਕ ਤਰੀਕੇ ਦੀ ਨੌਲੇਜ ਦੇ ਵਿੱਚੋਂ ਇਹ ਸਵਾਲ ਪੁੱਛ, ਦਿਸ ਇਜ਼ ਦ ਕੁਐਸਚਨ ਵੀ ਹੈਵ ਟੂ ਆਸਕ, ਦੈਨ ਵਾਟ ਇਜ਼ ਲਾਈਫ? So first of all, the starting point is that life is an emergent property. Now this word emergent property, what do you think it means? Okay, wait. Now that I shifted into English, I will involve you more. What's your name? Huh? Mandu? Mandu? Manjul. Okay. So, aging di nishani aa gayi na ek mere. Okay, Manjul. So we are going to talk about today. We start with Manzoor. Like accepted, ओके, मंजूर है, मंजूर है। 3 बार कह दूंगा तो हमारी शादी हो गई। अरे अरे वाह, तो that will be very dangerous. So allowed in India, can 2 boys can get married? Okay, so then there is no danger even if I say it 10 times. So yes, Manzoor, we are going to talk a little bit about what is emergent property. Yeah. That what is because life is an emergent property. Life is based in what? What is the basis of life? What is it made of? What are we made of? Huh? What are cells made of? Atoms. Do atoms just make anything together, or there is actually a little extra step to the atoms to atoms become molecules? Yeah? So basically the life is based in chemicals. That's a simple statement which we use in the teaching of chemistry. So life is based in chemicals, but are chemicals the life? कि जे थे अगर हम लेकर चले आए 10 किलो केमिकल का ढका तो वो कोई लाइफ तो नहीं बन जाएगा ना. So then what is life? That has been again this under observation that life is something very material, but then what makes matter alive? That has been a very big question all through history, all through thinking. That's why the explanations of soul and atma, etc. came into picture. That there is something which has to have some power of life. But science will not accept that. Yeah, because that again goes beyond humanism and beyond naturalism. Because then you get stuck into the nature of soul. Yeah, so nature of soul cannot be defined in naturalistic philosophy. Then you go into the derived knowledge. So if you don't accept the concept of some life power, life energy, that used to be called vitalism. Vitalism was the philosophy where that's where the vitality word comes from. That chemicals get a force of life, which is vitalism. And even scientists used to use that word instead of calling it soul, but they didn't know then how to define vitality. But then now we realize that life is actually an emergent property. Emergent property is usually that a compound or a chemical has one property and then another chemical has another property. But when they are together, they bring a third property which is not inbuilt into those two chemicals. Can you think of any example here? Exactly. NaCl. So, and what else? Any more examples? Most of the chemistry will give you these examples. Yeah, we often start with simple example of H2O, water. Why we take that example? Because from life point of view, that is more nearer example. But of course, even sodium chloride is again essential for that. So basically, you know that is the emergent properties. So first of all, we look into life as emergent property based in chemicals, but chemicals are not life. Then, okay, so if life is an emergent property, how do we recognize? Like water is an emergent property of H, 2 molecules of H and 1 molecule of oxygen. Individually, you cannot imagine the properties of water from these two. That this is a life-saving molecule, so all those properties. So if we want to talk about then life, what are the characteristics of a living system? So we take some, I have to try also to bring in as many people as possible, so that nobody sleeps. Yeah. So once in my Danish class, I was saying, "Hey, you cannot sleep in my class," and she said, "Yes, sir." No, not yes, Suresh. Yes, I cannot sleep. You speak so loud. So that's why I have to speak loud. So the characteristics of life. What are the NASA has set a long at defining what is life, because how will we find life on Mars or life on Jupiter? How will we recognize that this was a living system or not living system? So what do you think? That's where we left yesterday. Hanji.
As far as all the living organisms that we know to date on Earth, still all the living organisms have DNA.
Okay.
This is what is the chemical material. So also made up of chemicals, but that is the thing which is present in living organisms only.
in the present state of evolution, we think that all living organisms have DNA, which is perfectly right. But there was a time where living organisms were only based on, because life, there is a theory, originated actually from RNA. Yeah, that was all. Yeah. Yeah, viruses are still, that's why we put them on a little boundary on that side, that they are not living. So that can be one way of recognizing. So that just means that life has always, has to have DNA. Huh. Huh. No, but that material in itself, if we find in something, then we say it's living. Yeah. If I make a machine or some kind of a structure in which there is DNA, will it be living? Right. So that's why, okay, that's one requirement you have given, that it should have some kind of, at the present, DNA. But that's not sufficient, yeah? Even in the present life, because I can make things containing DNA, but they may not be living. What other characteristics of living system? Exactly. Yeah, that's very important, again, part, that they are able to continue, reproduce, and develop. Anything else? Growth. Give me word, just throw. Exactly. So, yes. That's a big, wider concept. What does that mean, survival ability? Because living system is, okay. Yes, yes. Yeah, because that survival ability can only be seen in the living system. Yeah, but the day I die, so was I not living system even? Because ਜੇ ਤੁਸੀਂ ਮੇਰੀ body ਨੂੰ ਉਸ ਸਮੇਂ ਦੇਖੋ, all those other chemicals, etc. will still be the same. So that is one part. But all these words, yes, you wanted to add something. Conscious. We come to a little higher level of that. That makes life even more difficult. Actually, that's the most fascinating area in cognitive neurosciences also. What is consciousness? How do we know? So, Anji.
When we say starting from an atom or subatomic
Anji.
level to the cell,
Hmm.
where we say cell is a living entity. So how do we define where life actually starts and this from subatomic to the cell level?
That is where we are trying to bring everybody together. That all those chemicals individually, a DNA molecule is not a living thing. Yeah, RNA or protein or anything individually, they need a minimal certain level of organization, which biology thinks is a cell, with the formation of cell. But then do we call a cell alive? Unlike yesterday where we used too much time, so let me go for. So emergent property, and if all these ideas we have to combine in a formalized language, NASA's definition of life is this. It already starts giving some clues that life is a self-sustained chemical system capable of Darwinian evolution. This is actually the practical definition which NASA uses. Here the biggest problem is Darwinian evolution takes sometimes very, very long length of duration, millions of years. So if we go somewhere, that will be a challenging part to show. Either we will have to show that that life which we see at one time on Mars has gone through the process of evolution, so that you should be able to trace backwards that there are millions of other types of forms also there, even if nobody is alive at that time. That is what their definition, that's why they say. Just finding one little thing there, we cannot say that is the living system, that's the proof of life. Because proof of life must say also self-sustaining. That's a very crucial word which becomes important for aging research later on. But then, what do you mean by self-sustaining? What do you understand? ਇਹਨੂੰ ਕਿਸੇ systematically ਕਰੀਏ ਨਾ, either I should choose the people, otherwise I get confused. That everybody should hear it. So self-sustaining basically meaning that, yeah, maintaining itself. So what does that mean, maintaining itself? Either you.
external assistance.
External assistance means what?
It can grow by itself.
Yeah, but grow by itself. Look, a machine, a robot, which will be created, it might be able to repair itself by taking the things. Yeah? You supply all the parts, and so intelligent robots are coming, and they will be doing a lot of these actions also, stability or self-defense, and a lot of characteristics of life which we are talking about will be seen in robots. So are they living systems? Yeah. Then why are not they living systems? Because they don't have the soul or something else? Huh? They cannot run. Well, the intelligent robots will be. If one robot machine you make and it is lacking some part, it might be able to say, depending upon the need of the work, it might be able to use some other things and create that part. So will we call it is evolving? The concept of consciousness becomes very critical in that issue. Will a robot anytime have consciousness? In many films it has got consciousness. Yeah? You can fall in love with robot can fall in love with you, and then the problems start. So what do you do? So again, then there is a practical definition of life given by a biologist, which is much more complicated. A system which is self-sustaining, just to compare the two viewpoints. Self-sustaining means by utilizing energy in the forms of nutrients, light, owing to its internal process of component production. Yeah? As coupled to the media via adaptive change. This is a bit complicated. That's the Italian philosopher's way of saying things. The important thing here is that when I grow not by incorporating cells from outside. I take nutrients and then the machinery converts it into the living part again. We give grass to the cow and we get milk. No machine has yet been even thought theoretically how that will be possible. Yeah? Because there is no correlation chemical level or structural level between grass and milk. But there is this big black box or a white box, and grass goes in one side and milk comes out on the other. That is one requirement of a living system of life, that it maintains itself by taking, as you said, without external help, but help is in this form, that you need a robot, as far as we know until now, cannot do this. You have to give robot a finished component. Then it can make another arm into that connected. But it cannot make that component by taking silicone or whatever else is needed. Yeah? So that is the distinction between living. So, and that story of robotics is becoming very interesting and challenging, that soon human robotic interaction is becoming so much that it's very difficult to distinguish between what is living and what is non-living. These days the outsourcing, when you phone someplace for help, etc., you can never tell whether it's a robot answering your questions or there is a person sitting in Bangalore who is answering your outsourcing call. It hasn't come that far all through, but it's becoming more and more, because you just need better algorithms, better voice systems, and we are already unable to. Robots are already ordering things. You can ask your robot to fix an appointment in a restaurant. Can you book my seat for 2, please? And the booker doesn't know who is calling. Yeah? So that will create this interface between living and non-living even more troublesome. But for our purposes, we start with this kind of understanding that, okay, a living system, the life must satisfy these criteria, that it's able to, again, you have already said those, grow and reproduce and self-sustaining by making use of the energy. And that property, this property of survival, somebody used that word, including adaptation. Like in the previous definition, there was a word self-adaptation. That property in your textbooks, you read it as one word. Do you remember the property of living systems to grow and adapt and respond and stay? What is that property? Anji? No, the technical word which is written in textbooks you use all the time. जिन्हें भी कहा, even if you are speaking spontaneously, speak it loud so that everybody hears. Huh? Hanji? No, that's a Darwinian thing. The property of, Hanji, do you say? No, that's a Darwinian, that's a process of natural selection. The property of living systems to counteract internal and external sources of disturbance. Ah, total laya hoya tusi unna definition nu bhul gaye ho. Hanji. And you got 100% marks in your pre-medical or wherever. Yeah, that is what you are told, homeostasis. What does homeostasis mean? Two words, homeo and stasis. What do they mean? Homeo means what? Same. And stasis means? Stasis means state. Same state. Is that correct definition? When are we in the same state? But we always use that word even now. In 99.999% of the publications, the word homeostasis is used. Yeah? Because this term was coined by engineers in 1930s, that a machine made needs a certain normal set point. Yeah? It should always keep the same state. There is small variation possible, but then it should come back to that. So that is the state of homeostasis, which machines without which cannot work, they collapse. Thermoregulation, it cannot tolerate large variation. And at that time, even in science, the idea about the body was that our body is a machine. Do you agree? Is our body a machine? Well, okay. Well, you have to justify, because I will already tell you that that's a wrong view. So let's argue on that. And in modern biology, nobody considers body as a machine. Body is not a machine. But that view is still very dominant. Just if spontaneously you also said that. Why? Why body is a machine?
So it was so many complex systems and functioning that is going on. There is an input and output.
Yes.
And processing.
Mm-hmm.
Much beyond.
Yeah,
There
there are some similarities. But if we start approaching body as a machine, its implications are very different and mostly wrong implications. You know, if you have a machine, a little washing machine at home, so it's not going to grow up or do something or make a little washing machine. It will be very nice to have this. So that machine analogy, what you said, complex system, and there is something that was used, but that was when we didn't know the complexity of biology, that biological systems are very, very dynamic. Every day we are changing and we are the same. Yeah? But any unit of time you take, you are changing and you are the same. We are not changing in such a way that suddenly one day I wake up and I am an insect. In one of the world famous stories, why I use this example, that's a very world famous story, Metamorphosis. It's a Czech author, Franz Kafka. So he wrote this story, it's called Metamorphosis. So one day this writer, he wakes up and he sees, oh, actually he has become an insect. And now what happens? How his family is going to react, how his society is going to, it's an amazing story. I think he got Nobel Prize based on that or some other one. A very, very important Czechoslovakian, now there is no Czechoslovakia, but at that time it was Czechoslovakia. So Franz Kafka was his name. So there is change, but it's not such a change that we completely change. So this term, which we have then terms called homeostasis, allostasis, and homeodynamics. Yeah, these are the three terms in the literature. Most commonly, biologists still keep using homeostasis, and it's a matter of just habit. They all know that biological systems are not homeostatic. We are all the time changing. But still, it's very difficult for scientists. Okay, we are as conservative and creatures of habit as anybody else. Homeostasis lafaz jada hai, it has become so ingrained in our minds, we keep using it even though we mean it actually dynamic system. So somebody, Yates in 1994, he coined the term homeodynamics. Yeah? Okay, this is the same body whose dynamics are the same. Dynamics basically mean interaction and this whatever rearrangement. In between there is a term called allostasis. What do you think it means? Yeah. Exactly. So you know the word, yeah, from immunology we know the word allo. So allostasis means different state. So they were talking about all the time anything which happens to our body is constantly changing it, changing the state. But that also ignores the dynamic nature, because the state change in dynamic nature goes forward and backward. You know, sometimes when you are ill, your immune system is so activated, everything is gone crazy, but when the infection has been taken care of, it has to kill billions of cells and re-attain the dynamic state. It is not stage into the changed state. But that's the one measure that you can measure things happening by measuring allostatic load, they call it, that how much change has happened. So then the word homeodynamics I like from 1994, that is the property of living systems. A child is born with certain power of homeodynamics, but it is not enough to keep it alive, so that's why the red zone is there. But when it grows up, growth, development, maturation happens, there is still a red zone, which is the danger zone, where things can go wrong, but generally in a normal, healthy situation, which is again a very difficult concept, we have this idea that yes, all healthy people have a healthy homeodynamic ability. Yeah. So then comes, what are the components of homeodynamic ability? I think that is where we wanted to finish yesterday. I wanted to give you the homework for that. That think about so we shift the lecture to the other. So what do you think are important components in categories of homeodynamics? And I then coined the word about 15 years ago, that this whole ability we will call homeodynamic space, that all of us have a survival ability, capacity to live, based in the processes of homeodynamics, but homeodynamic space is one way to think. If we want to say who is healthy, who is less healthy, who is young, who is old, will depend upon what is her homeodynamic space. But what should be the parts of homeodynamic space? Considering which are extremely important for survival. Like basically metabolism is not part of homeodynamic space, because that's the common factor. Krebs cycle chal raha hai. The idea, okay, clue given, self-sustaining properties. So how do we maintain ourselves? In some examples of self-sustenance, self-maintenance, what are the things which are important? Loud, please. Wound healing is one at a cellular level. Fine. Nutrient means what? No, that I already said, that that's a basic metabolism. Yeah, that is not a defense mechanism. So homeodynamic space basically means this processes of self-sustenance, self-maintenance, which are the important part of life. What keeps us alive? Metabolism, these are granted things, without electron transport chain. Okay, one is coming the repair of damage. Okay, I agree that with one category. We will go into details what kind of damage and what other is needed. Hanji? दो बंदे बोल रहे मेरे है तो दो कान पर सुनदा एक चीज है एक साथ. I didn't. Hematopoiesis, that's a very specific act of making blood cells. Yeah. Is that a universal property for all living systems? Yeah. So we are trying to find some universal properties, because there are systems where hematopoiesis is not there. They are living in some different way of fluids.
The reflexes when we see something danger or
yeah. What do you think? Okay, yeah, that's right. That's called the power of adaptation. That all the time we are going through disturbances, changes, and if we are not able to respond and adapt, then the living system will not survive. Yeah. So that is also known as stress response, basically. So stress response is a very, very major aspect of survival. I am choosing those areas which are relevant for our aging research, because the course is still on aging. There is a third Actually, we have covered the second one also. This adaptation, we also use the term for that, remodeling, constant remodeling. All the body is going through remodeling. Old things are being removed, new are being brought in, especially in immune system. Constantly this remodeling is happening. In skeletal system, osteoblast, osteoclast combination. That is a very, very important survival side. The system which wound healing will come under that category. That when something has gone bad is trying to heal it. But that's by remodeling those cells which were not dividing. Now they, Hanji, sorry.
In that sense, like our skin, which is the largest organ of the body,
Yeah.
that plays very important role because we know the wear and tear of the skin lifelong, and the new cells are being formed. So, what is the importance of this top layer being, say, dead cells, retinal cells, because it is there for protection, and the dead cells and the low pH of the skin, between 4 to 5, helps us in protection from the entry of the microbes. Because microbes, and not only the skin, outer covering, even the internal body lining, all your mucous membranes, although the mechanism is little different, there the mucus and the ciliated nature of these lining cells, they help in wrapping the pathogens and pushing them out of the body. But skin, as the first line of defense, which we call the innate immune system as the anatomical barrier, it helps in prevention or in protection against the microorganisms which may get entry. So both the nature of the cells, the top layer, and the low pH, acidic pH of your skin helps in protection from the invading microorganisms.
So tomorrow and day after that part, she will develop much more. That will be one of the questions were asked, why we study different parts or organs. What's the significance of studying aging in skin or brain or muscles or bone? Yeah, that will be there tomorrow and day after 2 lectures. Mostly Gurcharan will take that, talking about these justifications. I am just giving you general concepts of, because we still haven't reached the question raised yesterday, that why we have a limited lifespan. Yeah? So, but we need to understand what is life, first of all. And life is, this is what you have been now adding to that. So 3 major categories of components of homeodynamic state: stress response, damage control, and constant remodeling or adaptation. This is what is central to life. And of course, all these processes are based in biochemistry and genetics. There are hundreds of genes involved. You can take any damage control pathway, DNA repair. More than 120 genes are involved in that. You take protein turnover, proteasome, whatever. Each, and those are called longevity assurance genes. That genes which are necessary for having some lifespan, without which you cannot live. Or if you don't have those proper genes, you will have very serious problems. That is what gives us life. And so first message here is that yes, life has these characteristics, but our molecular biology then involves genes and proteins and all that. So that is internal to that. So then what is then next? Survival and death curves we might go through. So again, how do we draw living and dying thing? I'm going to then jump over that. How do we measure population's rate of death? How speed, in which speed it increases in different species? That gives some rate of aging or rate of dying in different species and explains the question why different species live shorter or longer. But this will take us away from the mainstreams there. But there is one way, that you start with an experiment. If you want to do an experiment in the lab, so you start with 1,000 animals, and then you are trying to see how many animals are alive every day. Yeah? And that will be in a wild population in nature. This is the kind of curves you see. There is a high death rate and they die. But slowly this is what has happened to humans. This is where we stand now. There are very few deaths that happen earlier, then deaths happen and die. Or the same things can be drawn other way around, the number of deaths which increase. There is always very high death in early ages, but then it increases exponentially. And usually we compare, it's called the mortality rate doubling time. Some of these things are written in the book. Yeah? Like human beings have every 7 years, our chances of dying become double. Whatever my chance, and that starts from age about 12, just after puberty. In human beings, mortality chances start increasing from the age of 12. Whatever chances at age 12, after 7 years it becomes double, and then double, and double, and double. But whereas in a rat, that is only 3 months. Yeah? The chances of dying based on these population studies will show that. So then we say, which has such a high, that will have a shorter lifespan. Shorter and longer lifespans are compared by data from populations in zoos, experimental, whichever way, which tells which is going to live shorter or longer. It already tells that when the rates go up and down. Then comes this, again, evolutionary reasons, okay, then why we die. Death is there, even evolution also, all the time. Why evolution allows death to happen? Because if the systems are made to live life and reproduce, but then evolution has not kept them forever. So why evolution allows death to happen? Do you see any advantage or disadvantage of aging and dying? I'm going to ignore you for a second. So, Hanji, somebody from here, I haven't heard your voice from this side yet. Okay, to maintain the population size, otherwise what will happen?
If a particular population is not dying
Yeah.
at a particular rate,
Uh-huh.
then there will be overpopulation and exploitation of the resources.
Oh यार दो बार फिर तुम बोल रहे हो एक दफा अच्छा that is what we intuitively think, and you are adding to that same. Okay, so who disagrees with this kind of thinking? So this kind of thinking says that evolution knows in advance that if I allow populations to grow too much, it will be very dangerous. And you have studied Darwinian evolution. Is that the way evolution works? Does evolution plan things in advance? Tharo. Hanji, yeah, your no is right, but I'm going to ask why. Any answer, why you should be ready with that why part. Hanji, to see kya. Okay, what were you were saying something, Justin? Okay, all right, sorry. They spotted you, you need to. Hanji, why no?
So survival of the fittest. The load of the population is high. Then the main impact on the back will change. That will exist. So if one level will be disturbed, then the whole chain will get disturbed.
Yes, and then?
Then there will be disturbance and the survival for the fittest come into account. The particular species or population that will survive in that condition will promote to the next level unless that retains.
Yeah. No, but does then evolution need ways to kill the organisms? Like according to her, that there will be, yes, if there is too much crowd, if there are resources are used up, it will be a survival problem for that species or population, and then it will disappear in one go. Yeah? And should evolution prepare for that already and find the mechanisms to kill certain numbers all the time? Does evolution work like that? Can it think beforehand that, look, if they keep on reproducing, we are going to be in trouble? Does evolution work with this kind of? You started the yes. थोड़ा ऊंची ताकि दूजे भी सुनन जहाँ वो दियो जी माइक्रोफोन.
Sir, I think it has been
एक
planned.
ते सुरेश जी कहने की कोशिश करो. मैं सर 3-4 बार सुन के थक गया. हाँ.
Sir,
ओ सुरेश जी सर.
Suresh ji, sir. So I think it has been planned because if it had been not planned, maybe aging would have not been there.
Aha, okay. But planned, why? Why does it need to be planned?
Because there will be depletion of resources.
How does it know that there will be depletion of resources? Huh? If you have two groups of animals, one is reproducing very fast all the time, and the other one is being killed by evolution, who will win?
The one who is surviving and
Right.
reproducing.
Yeah. The survivor. But we see in nature, surviving population are, well, everybody has a limited lifespan. And sooner or later, in different conditions, they will die. But whereas in the natural competition, the one which does not die will win.
Yes.
Huh? Will always win, whatever. So the idea here generally again is evolution does not work by planning. In evolution, things happen by natural selection. Selection means basically whoever wins. Wins in evolution terms, whoever wins at that time in terms of survival. So there is no advantage for killing the organisms. The reason is, again, this kind of graph, whereas this is actually still much better. That's a human graph from 50,000 years ago. That's how populations were dying. But in nature, the speed of death due to predation, infections, accidents, animal eating animal are so high that the numbers of enough animals is a big problem for evolution. Not that too many numbers, but too little. The problem in evolution is to have enough numbers surviving so that the species continues. And they are never there. So, ਇਹ ਜਿਹੜਾ method है ना कि population ਦੀ ਭੀੜ ਪੈ ਜਾਏਗੀ ਤੇ society evolution ਨੂੰ ਕੋਈ mechanism ਚਾਹੀਦਾ to kill the numbers. That has never happened. And it will never happen in evolution. It only happens in controlled condition. We have maybe problem now. Most of us may not be alive in the natural conditions of evolution about 1 million years ago. ਸਾਡੇ ਚੋਂ ਬਹੁਤਿਆਂ ਦੀ survival would have been, we have been killed. Average age, even in Roman times, was considered to be about 20 years. Very, very few people were living beyond that. Infections, vagara. Actually change hoya curve, that has happened only in the last 100 years. So evolution does not need to kill. This is the problem of our modern times. Evolution never had that problem. It did not need to create mechanisms to kill. It needed all the mechanisms to live. But the fact is, we still die. So that is where the question of aging and death becomes even more concrete. कि जे evolution दी the problem ही ये रही है. So then how do we consider? So there are what we call the evolutionary theories of aging. Different viewpoints are given here. The first part which we have just rejected, that's also called the adaptive theory. Adaptive theory means there is some use of aging and death. You need it, therefore it is there. But there is no adaptive reason. The reason is non-adaptive. So few organisms surviving, which is not a selection pressure, that evolution doesn't need to do anything about them. They are going to die anyway due to whatever reason. So evolution just forgets you because the purpose of evolution has been fulfilled. So that's called evolutionary neglect, that it allows things to happen because it doesn't give a damn after reproduction of the system. Or it's called genetic dustbin. Okay, whatever changes are happening, mutations are happening, evolution tries to push them so that it does not kill the animals in young age without performing the purpose of life. So then all those is like postponing it. So mutations accumulate and then the systems will collapse. But they cannot accumulate up to certain age. Or antagonistic pleiotropy. Yeah? This is called that sometime evolution needs some kinds of genes which are good for living, but the same things become bad later on with time. Yeah? Special examples are like cholesterol metabolism. During growth development, that's a very, very important pathway to accumulate. But if you keep living long enough, that's exactly what will give you lots of problems. In modern societies, that's the biggest problem of antagonistic pleiotropy. Our bodies are made to store food because food is always the biggest problem in nature. But now we have food all the time. Yeah? So as a result, there is obesity. So this is also called the thrifty gene. It's a very fascinating area to understand, and you should read more about that. Okay, what are the possibilities? Then comes a very important theory called disposable soma. Can you guess any meanings of that word? Disposable soma theory. That beneficial will become more in antagonistic pleiotropy. Antagonistic pleiotropy mean antagonistic mean opposite. Pleiotropy mean multiple effects. Because the same thing which may be good might have bad effect or some new effects which are not part of the system. Yeah. But disposable soma is one of the most powerful experimentally testable theory, which was, and why I like it, it was being given parallel when I was doing my PhD with Robin Holliday. There was another student called Tom Kirkwood, who was a mathematician. So he was developing ideas on disposable soma theory. So disposable soma theory was given by Tom Kirkwood, who is still active. We were both class fellows almost. I was more experimentalist, he was more theoretician. So we were combining. Disposable soma is actually based on, in biology you have studied Weismann's distinction between germ line and somatic line. Huh? What is that distinction? What do we mean by two lines? Our bodies have two types of cells, or two lineage of cells. You know, what is the germline lineage? So what are the cells in germline? What are they called? Yeah, okay. So the other cells are called somatic cells. Yeah. So that was Weismann who was dividing these things. Yesterday we were talking about the immortality. Is there anything immortal? We were taking examples of bacteria and other to say that there is nothing immortal. What about germline? Is that immortal? Because I forgot yesterday, then in my notes I thought, oh, we didn't bring that. Because we were talking very strongly that there is nothing immortal. But what about germline? क्योंकि जे germline immortal ना होंदी ते तुसीं असी इत्थे नहीं हुंदे. असी इत्थे we are here because our parents were here and parents and parents all the way जिथों तक भी जाना चाहते हो.
There is concept you told yesterday, mother cell will die and the others will.
Yeah. So what will be?
Die. So we can't say that germline is.
Germline is a different concept. Germline means cells, or if you take the DNA as our basis of life, we are all carrying in some way the original DNA. Because if that was not possible, we will not be here. So the immortality of the germ line so far looks like that germ line is immortal. But what about germ cells? Is egg immortal? Is sperm immortal? No. That was yesterday's example also. Bacteria may look like immortal as a population, but individual bacterium ages and dies. So individual germ cell also ages and dies. Sperms from old people have much more problematic situations in fertilization, in causing genetic diseases. Same thing about old eggs. Yeah? So aging of germ cells happen, but aging of germ line is a different situation. We don't know. Maybe in some species, even that happens and they disappear. Some people think that a average species lifespan is maximum around 300,000 years. So then it disappears. We don't know whether how to test it more on that. Again, Hanji. Huh. But line stays now. ਉਹਦੇ ਵਿੱਚ ਕੋਈ ਨਵੀਂ ਚੀਜ਼ ਨਹੀਂ ਆਈ. So we haven't got any new ways of making new life, as it's a DNA based story. Changes are happening. That's why we are all different. Yeah, we are carrying the same genetics coming from our parents, but that's where the meiosis and fertilization creates the new combinations. So new combinations are created, but no new. We are all carrying 23 pairs of chromosomes. Yeah, we are all carrying something called a human genome. Yeah? But we are all different. We will be soon coming to that question also. So, yeah. Huh. Right. You're almost right on that. That's what Tom Kirkwood was trying to say, that our body has these two types of lineages, somatic cells and germ cells. The life perpetuates through germ cells, but somatic cells are just carriers of germ cell, and they are only needed for that purpose. So they are disposable. Yeah? But whereas the germ line is not disposable for evolution, then life will finish. So our body cells are disposable, just like the example here, like these disposable flask. It should carry the water, but for short time. You can make this flask also of some material which never degrades, never goes wrong, perfect material. And to drink water, it will be impossible to then use that, because it will be so expensive in terms of natural resources or energy. Yeah? So basically the body has limited ability to divide resources. So if you take care of the somatic cells, you have to pay the price at germ cells. So body is just needed enough to reproduce. Yeah? If you want to send a machine to Mars, a probe, you need to guarantee that it reaches Mars. Yeah? After that, you don't need to switch off it. It should reach and work for 180 days or whatever. So you have to assure longevity assurance. But then you don't need to put bombs in that, then no, it should stop working. It will stop working because that's a machine, something will go wrong. Yeah? But you don't have to put the mechanisms. So same theory, disposable soma theory, says that evolution puts in mechanisms so that our bodies can fulfill the purpose of life, which is reproduction from biology point of view. And then it allows things to go wrong. So that's and this can be tested. And in experiments, and lots of experiments have been done on that. The one extension of this experiment is that if you try to protect the somatic cells too much, then body will reduce the protection of germ cells, because it cannot use unlimited resources. There is a intrinsic thermodynamics limitations come there. We are getting into too much of, again, my talking. So what is the implications of evolutionary theories of aging and death? Okay, what does it mean then? Does it mean that will we have any killing mechanisms in the body? Will we have gerontogenes which cause aging? Because that is the most important implication. And that has taken gerontologists 50 years to reach this consensus. Okay, lifespan is not pre-programmed. We still study program theories of aging and this and that. Individual level, not at all. And there are no gerontogenes. Like 2 days ago, Gurucharan also said in her welcome address that I coined this term in 1984. just for the sake of discussion, because at that time they had this term oncogenes. Yeah? So cancer people had oncogene, aging people didn't have a term. Oh, we are also looking for genes, what should we call them? ਉਹ ਫਿਰ ਜਿਵੇਂ ਹੁੰਦਾ ਨਾ ਬੱਚੇ ਦੇ ਪਹਿਲੇ ਜੰਮਣ ਤੋਂ ਪਹਿਲੇ ਹੀ ਉਹਦਾ ਨਾਂ ਰੱਖ ਦੇਣਾ। ਸੋ ਨਾਂ ਮੈਂ ਪਹਿਲੇ ਰੱਖਤਾ ਕਿ ਜਦੋਂ ਵੀ ਲੱਭਾਂਗੇ ਨਾ ਕੋਈ ਵੀ ਜੀਨ ਜਿਹੜੇ ਏਜਿੰਗ ਕਰਦੇ ਆ ਉਹਨਾਂ ਦਾ ਨਾਂ ਹੋਏਗਾ ਜੋਰੋਂਟੋ ਜੀਨਸ। ਤੇ ਬਾਅਦ ਚ I have spent all my life trying to prove that there are no Geronto genes. So that may be also a rare example that you give a concept and then you spend your life trying to destroy the concept. So, but that is where we stand in terms of genes, that there are no genes. So don't look for any genes which cause aging, which has implications again with intervention story. Because if there are genes which cause aging or cause problems like that, which evolution has made, then it will be theoretically easy that one day you neutralize the gene or cut it out and make some other gene. Huh? But the implications of evolutionary theories, when there is no gene, what do? मार फेर भी रहे हैं, बुढ़े भी हो रहे हैं, प्रॉब्लम भी आनी है, and but there is no enemy there inside the body, and that changes the whole approach to science. So this is one of the most important implications of homeodynamic space, which is based in longevity assurance genes. So genes are there. Don't think that I am against genes. I am against the gerontogenes. That there are no genes which have evolved in evolution. Because the question again comes, why couldn't they evolve? Do you think gerontogenes could have evolved? Because एक population de which after all aging te ho rahi hai na, there may be a gene which is causing it. So why do we say there are no gerontogenes? Can gerontogenes evolve? Can evolution select for gerontogenes which kill the system? Oh. No, but if there were genes, will evolution love it or not? If there were genes which happened by chance even, that they were killing the system, will it allow it to increase? What? How? That will be removed. Yeah, then the selection will be on that, because all genes are open to mutation. Even if you start with a population which has gerontogenes, there will be by chance, what is the mutation frequency in nature, in our cells? Again, numbers games are always fun. Anji, what's the mutation frequency? Find out yourself. Okay. Anji, 1 out. You're all guessing now, yeah. Be strong, be confident. 1 in a million in every kind of gene, whatever. Okay, we accept that. But the range is between 1 in a million or 1 in a 10 million or 10 million, that every time DNA divides for each base, that is the chance things will go wrong. So even if there were gerontogenes, some populations will emerge where that gerontogene has become inactive. Huh? So then that will become immortal. It will not die and it will win. The same thing, but it hasn't happened. No immortal population has emerged. So that is, so then why do we call them gerontogenes? Yes, genes are involved in aging in terms of that was then after 1984. Then after 10 years I wrote another paper calling gerontogenes are virtual. They are not real, they are virtual. That after all everything is happening due to genes, but when you will look for genes which are giving problems in old age or life, and you can call them gerontogene, but that will be virtual because the real will be something else. DNA repair genes are found to have very important role in survival, but they are not there to cause aging. When they are unable to do anything, or then they virtually become, or insulin pathway, all the genes identified so far which are called aging genes, they are actually survival genes. But it's only when things go wrong with them that they do these bad effects. It's the same, like in biology we often use wrong terms. Werner's syndrome gene. You have heard the Werner syndrome? Werner syndrome is a disease where one mutation in one gene's 1 point mutation makes people become old very fast. Yeah, they progeria, that's the same. Progeria is a category, but Werner syndrome specific, there are several variations on that. But they are point mutations. Then we say, ah, look, there is a gene for that disease. Yes, it's a gene when it doesn't do its job, normal job. Its normal job is not to allow that disease to happen. No. पर terminology इंज दी है कि as if that gene is the cause of Werner's problem or progeria. No, in its normal functioning style, that gene was the one which does not allow disease to happen. Same thing is for all other competition. We will come to that more often very quickly. Okay, Hanji.
Species which just reproduce and vanish.
Yes, sir, I was just telling you the same that lobsters are supposed to not age. They don't age. It's just that they die.
We are coming to that if we come today or tomorrow. In nature, what are the ways of living and dying? So let's see what was the next. So with that question, well, we might save the time here also. That deals with that there is no mechanisms to kill us. Evolution, so don't look for programs. Aging does not happen due to any program. Death does not happen due to any pre-programmed plan of biology or evolution. Again, today I'm being more cautious just to stay within our derived knowledge. So there is no other explanation from evolution's point of view. Then we have to find reasons why it still happens. And if we live long enough, one becomes old. And who is old? How do we know a person is old? Sometimes, again, depending upon number of students, we do that exercise with everybody, but here I can do with just two of you. Can you stand up a little bit? Just because bad luck or lottery. Like if you are both, you are actors, and you have to play the role of an old person. And in that, you have to go there and come back to your seat. And just how do you think you will play the role of an old person? Why I use this actor example? Because my son is a professional actor, so I always use that. Can you please do that little acting part as an old person? You just have a little walk and go back. Then I take some rest in the meantime. Yeah, I don't feel shy. It's a theater. Come on, guy. Just at least come to me and say me hello as an older person. Okay. All right, fine. Okay. Wow. Okay, that was one example of. But what was the difference? Did you walk in the normal way that you will be doing as a normal this age group person? So what was different? Although you didn't do. Yeah, my exercise didn't work very well because my actors are not very well trained. No, the one thing was that both of you walked slowly, and a little bit there was a bending of the body, and you even had to cough and otherwise. But the thing is that you did not walk in the same way as you are doing now at whatever age you are. So our image of old age is always towards loss of bodily functions. Yeah? Because sometimes those actors who make some extreme examples of totally bending down, then I ask them, is that the way I am walking? Is that the way I am talking? And they end up, no. But then say, but I am old. Yes, but not as old. Yeah? Now that is where the social concept starts coming. That when we even talk about old age, there is no one way to think about old age. I am also old. I will be older or whatever. Yeah? So those stages, yesterday we were talking about stages. Yeah, so out of that, when does the old age state begins? Did you find the Shabad? What is that? Loud, please tell everybody. Yesterday I gave her this homework that in cultures also, everybody tries to talk who is an old. So Gurbani has very clear Shabad written about different stages of life. Yeah? We talked about age as a stage. आज कुछ नवे बच्चे भी हैं they're all from, because I feel, और जो जड़े पीछे बैठे हो, are you all here also yesterday? ਸਾਰੇ ਸੋ ਫਿਰ ਮੇਰੀ ਮੈਮਰੀ ਹੁਣ ਟੈਸਟ ਹੋ ਰਹੀ ਹੈ ਦੈਟਸ ਅਨਦਰ ਏਜਿੰਗ ਦਾ ਪਾ ਹਾਂਜੀ
So it was basically it told that there are 3 stages of life.
ਹਾਂ
ਬੱਚਾ ਬਿਰਧ ਬੱਚਾ ਜਵਾਨੀ ਤੇ ਬਿਰਧ.
ਇਹ ਤੇ ਕਿਹੜਾ ਸ਼ਬਦ ਹੈ ਗਾ ਕੇ ਸੁਣਾਓ
ਬੱਚਾ ਸੌਰੀ ਬਾਲ ਜਵਾਨੀ ਔਰ ਬਿਰਧ.
ਹਾਂ
3 ਅਵਸਥਾ ਜਾਨ.
ਓਕੇ
So this was
ਇਹ
the
ਤੁਸੀਂ ਲੱਭਿਆ
Shabad
ਸ਼ਬਦ ਕਿੰਨਾ ਦਾ
I
ਲਿਖਿਆ
found. ਗੁਰੂ ਤੇਗ ਬਹਾਦਰ ਜੀ ਦਾ
ਨੌਵੇਂ ਮਹੱਲੇ ਸ਼ਲੋਕਾਂ ਚ ਓਕੇ ਓਕੇ but that was only 3 stages we already talked 4 5 6 stages
There was another Shabad, but it was more about the stages of mind that defined the 10 stages
okay
of mind.
what are those
So exactly I don't remember, but I have that.
are they stages of mind or well that doesn't matter but the thing is that the philosophers have been thinking about this question
Right.
stages of life in their own ways. She mentioned yesterday Shakespeare's one play what's the name of the play
Stages.
no that is
It is a poem.
yeah what was the name of the poem I'm
7 stages of life.
ਨਹੀਂ ਇਟਸ ਪਾਰਟ ਆਫ ਦਾ ਇਨ ਉਹ ਮੈਨੂੰ ਡੈਨਿਸ਼ ਚ ਯਾਦ ਆ ਜਾਏਗਾ ਜੇ ਕਿਉਂਕਿ ਉਹਦੇ ਵਿੱਚ ਨੈਵਰ ਮਾਈਂਡ ਸੋ ਸ਼ੇਕਸਪੀਅਰ ਡਿਵਾਈਡਡ 7 ਸਟੇਜਸ ਜਿਹੜਾ ਗੁਰਬਾਣੀ ਦਾ ਸ਼ਬਦ ਆਈ ਵਾਸ ਲੁਕਿੰਗ ਫॉर ਉਹ ਮੈਨੂੰ ਆਪ ਨੂੰ ਅੱਧਾ ਕੁ ਭੁੱਲ ਗਿਆ ਪਰ ਉਹ ਚੱਲਦਾ ਹੈ 10 ਬਾਲਨ ਪਤਾ ਨਹੀਂ ਕਬੀਰ ਸਾਹਿਬ ਦਾ 10 ਬਾਲਨ 20 ਰਵਣ 30 ਕਾ ਸੁੰਦਰ ਕਹਾਵੈ 40 ਸੇ ਪੁਰ ਹੋਵੇ 25 ਸੇ ਪਤਾ ਨਹੀਂ ਕੀ ਹੋਵੇ ਫਿਰ 60ਵੇਂ ਪੇ ਬੁਢੇਪਾ ਆਵੈ 70ਵੇਂ ਮਤਹੀਣ 80ਵੇਂ ਵਿਵਹਾਰ ਨਾ ਪਾਵੈ 90ਵਾਂ ਉਹ ਫਿਰ ਬਿਮਾਰੀ ਦੀ ਆਂਦੀ ਉਹ ਬੜੀ ਖੂਬਸੂਰਤ ਸਿੰਗਿੰਗ ਹੈ ਸੋ ਉਹਦਾ ਨੇ 9 ਜਾਂ 10 ਸਟੇਜਸ ਇੰਜ ਕੀਤੀਆਂ 10 ਸਾਲ ਬਾਲ ਅਵਸਥਾ ਪਹਿਲੇ 10 ਸਾਲ ਦੀ ਹੈ ਹਾਂਜੀ 10 ਤੋਂ 20 10 ਬਾਲਨ 20 ਰਵਣ ਤੋਂ I don't know what exactly I mean so that was just an example because I just took it for granted that you must know all Gurbani so maybe you don't yeah, that's all right but you tried that's perfectly all right so who is an old person that is what we will have to be discussing so that also comes to the question that this oldness then when does it begin again usually we take some time to discuss amongst yourself here I need your quick answers when in the lifespan in terms of number even or stage when does the stage of old age start when does aging begin koi ek bande de koi haji ha where is this number coming 40 50 I say from beginning from birth yeah that's what we say ਕਿ ਕਿੰਨੀ ਮੇਰੀ ਹੁਣ ਪੋਤਰੀ ਹੈ ਮਾਇਆ ਵਿਦਿਆ ਉਹ 2 ਸਾਲ ਦੀ ਸ਼ੀ 2 ਇਅਰਸ 올ਡ ਹਾਂਜੀ ਅੰਗਰੇਜ਼ੀ ਵਿੱਚ 올ਡ ਵਰਤਦੇ ਨੇ ਪੰਜਾਬੀ ਚ ਤੇ ਨਹੀਂ ਅਸੀਂ ਉਹ ਭਾਸ਼ਾ ਵਰਤਦੇ ਪਰ from birth or sometime even before birth so ਕਿੱਥੋਂ so what should we start
Sir, we are giving these numbers on the basis of the aging symptoms or the features that come up mental wrinkles or maybe bodily discomfort.
because that is what we understand aging ਕਿਉਂਕਿ ਜਦੋਂ ਮੈਂ ਇਹਨਾਂ ਨੂੰ ਕਿਹਾ ਹੈ ਕਿ how does an old person move you didn't start crawling for example ਭਾਵੇਂ ਉਹ ਵੀ ਹੋ ਸਕਦਾ ਹੈ ਇੱਕ ਲੈਵਲ ਤੇ ਜਾ ਕੇ so there is already some inbuilt part of the stages that what are stages when does aging begin
Yeah, because if we take the aspect of biology, we talked about how germline is how our body is only a mechanism so that it's a reproduction it's a reproductive body so women hit menopause at around 50 so it's just that we don't need our body as much as we do in earlier
well
stages.
thanks for helping that's where we are leading to yeah that's what we are coming to what I will give in my own way of saying it so aging basically starts in that period in lifespan when you are not needed by evolution anymore yeah but first of all that lifespan what will be that lifespan according to Darwinian theory so that's Darwin all his own aging so based on Darwinian theory we ਹਾਂਜੀ ਇਹ ਹਿਊਮਨ ਸਪੀਸੀਜ਼ ਦੇ ਬੜੀ ਕੰਪਲਿਕੇਸੀ ਆਣੀਆਂ ਸ਼ੁਰੂ ਹੋ ਜਾਣਗੀਆਂ ਕਿ what about man when does that because in evolution actually generally the male sex is irrelevant all selection process happens through female sex. So male sex, the mechanism, sometimes it varies too much. So unfortunately, that's why male have to create some other way of suppressing the female sex, because evolution does not prefer them. From evolution's point of view, they are absolutely, yeah, they're just for a variety. Yeah, Anji. Anji. Ji. Yeah, even thyroid and that we will come tomorrow and day after. Na? When things happen, what kind of things happen in which sequence or whatever. So that there is the types of lifespan. Yesterday we talked about 2 types of lifespans. You remember the terms? We talked 2 types of lifespans. What was the first type of lifespan? I gave a big table data. ਜਾਂਦੇ ਸਾਰੇ ਸੁਣਿਆ ਕਿਉਂਕਿ ਇਮਤਿਹਾਨ ਨਹੀਂ ਨਾ ਹੋਣਾ ਇਸ ਲਈ ਭੁੱਲ ਜਾਂਦੇ ਹੋ. I showed one big table of 200 countries. What kind of lifespan was that? ਹਾਂਜੀ ਐਵਰੇਜ ਥੋੜਾ ਇੱਕ ਤੇ ਉੱਚੀ ਬੋਲੋ ਯਾਰ. ਹਾਂ ਉਹ ਇੱਕ ਸੇ ਐਵਰੇਜ ਇੱਕ ਦੂਜਾ ਲਾਈਫ ਸਪੈਨ ਦੀ ਟਰਮ ਮੈਕਸਿਮਮ ਤੇ ਫਿਰ ਤੀਜੀ ਬਲਾ ਕਿੱਥੋਂ ਆ ਗਈ. ਇੱਕ ਤੀਜੀ ਬਲਾ ਇਹ ਹੈ ਕਿ what evolution needs and that we call essential lifespan. What is needed by evolution, that is also my term I coined about 15 years ago, which is now quite accepted to understand this way, to answer the question of when aging starts. So aging starts if you live longer than your essential lifespan. So oh the number, even though you played with the number, so average number calculated is for Homo sapiens is 45 years. Very depressing number, because we all expect to live double than that. Some person has lived 3 times than that. But from evolution's point of view, we are not needed as a Homo sapiens, because the purpose of life Homo sapiens is reproduction. Again very depressing. क्योंकि ये भी कोई पर्पस होया कि यही पर्पस कुत्ते दा है, बिल्ली दा है, चूहे दा है, कीड़े दा है, यही पर्पस तुहाडा ते मेरा है. नहीं वो species does, because then species will disappear na. Evolution works on, I use the term longevity assurance processes. Longevity assurance processes are assurance of the lifespan of the species, and that is essential lifespan. एक Drosophila ਦਾ essential lifespan is about 7 days. पर ਜਦੋਂ ਤੁਸੀਂ ਉਹਨੂੰ ਲੈਬੋਰੇਟਰੀ 'ਚ ਲਿਆ ਕੇ ਐਕਸਪੈਰੀਮੈਂਟ ਕਰਦੇ ਹੋ ਉਹਦਾ 1.5 ਮਹੀਨਾ lifespan ਹੋ ਸਕਦਾ. ਇੱਕ ਚੂਹੇ ਦਾ essential lifespan of a rat is less than 1 year. In the laboratory it's 3 years or more. So essential lifespan of Homo sapiens is 45. Not a fixed number 45, again in a dynamic way from 40 to 50, but that reproductive peak comes, and that is when aging, we can say, start. So then becomes the problem, okay, is that our purpose of life? Yes, as a Homo sapiens, that is our purpose of life. But then as a human being, that is a totally different story. So we are now we come into sociology. Okay, what is the purpose of life of a human being? Because Drosophila nu MSc PhD नहीं करने दी लोड़, and even Drosophila or a ratus or a whatever macaca, they don't have to become anything. They just stay what they are. At least that's how we think. They might be thinking something different about them, but we don't know. So they just live as a Drosophila melanogaster and die as Drosophila melanogaster. We are born as Homo sapiens, but we have to become human beings. And that is a fascinating question in itself. What makes us human? That's where all the, and that you might get some of the taste from the sociologist. Okay, because that is the whole question of sociology. Human beings then created art, language, literature, music, religion, science, education. This is not the purpose. What you are listening to here is not the purpose from evolution's point of view. So aging starts the day you celebrate basically your 45th birthday. 18 years ago when I celebrated my 45th birthday, that is when I entered into old age. ਹੁਣ ਮੈਂ ਕਈ ਜੋ ਮਰਜ਼ੀ ਜਾਵਾਂ ਕਿ ਇਸ early age, ਇਸ middle age, ਇਸ this and that, ਪਰ ਹੈ old age. This is only going to become worse and worse. ਉਹ ਅਸੀਂ ਆਪਣੇ ਆਪ ਨੂੰ ਧੋਖਾ ਦੇਣ ਲਈ ਜੋ ਮਰਜ਼ੀ ਕਹੀਏ, ਬਿਕੋਜ਼ ਦੈਟ ਇਜ਼ ਆਲਸੋ ਡਿਪੈਂਡੈਂਟ ਅਪਨ ਹਾਊ ਆਵਰ ਸੋਸਾਇਟੀ ਹੈਜ਼ ਡਿਵੈਲਪਡ। ਡੂ ਵੀ ਸਰਵਾਈਵ ਬੈਟਰ, ਆਰ ਵੀ ਗੋਇੰਗ ਟੂ ਲੁੱਕ forward to living long age? So now the question comes, how to live in old age. You want to add something? Okay, because I thought you were doing that. So that is again a very depressing message to be given to both scientists and to public, that yes, aging does not start from birth. So that's why now I have cut the painting. Aging starts other part of the thing. If we live longer than our species essential lifespan, that is when aging starts. And then some people will live longer and some people will live shorter. Okay, I was also thinking about that yes. So okay, so this is, so we stop here. This is where biology basically comes to an end in terms of intellectual questions of why aging happens in evolutionary terms. Take a break please, I also need to drink.
We have arranged some refreshments which will be served here.
Now in but then we will use another hour or so or something after that. Okay, that's better.
Fruits today. किसी की preference है?
नहीं फ्रूट ही कोई जो हैगा ते की हैगा, कोई केला हैगा ਜਾਂ ਆਪ ਸੇਬ ਹੈ ਕੀ ਓਕੇ ਜੋ ਕੱਟ ਕੇ ਖੋਲ ਕੇ ਨਾ ਲਿਆਏ ਹੁਣ ਕੋਈ ਵੀ ਚੀਜ਼।